right, so I think that we are live now. So what I want to do is really welcome everyone who's joining this briefing on such quick notice to deal with such an absolutely terrible situation. There have been a lot of questions about what happened meteorologically, what the climate connection is, what this means for people on the ground. And so we brought together this group of weather and climate experts to discuss that and give you a chance to ask your questions. So let me introduce our amazing crew that we've got with us today. First, I have Shel Winkley. He's a former broadcast meteorologist. He lives in Texas. He is a deep part of the Texas weather community. He has been with Climate Central for about a year now, and he is a meteorologist and weather and climate engagement specialist. Also, we have Fredi Otto. She co-leads World Weather Attribution. Many of you are already aware of the amazingness of Fredi and all the work that she does. But for those who are newer to this, World Weather Attribution is the group that can do these deep dives on extreme weather events, really quantify the role of climate change and how that's impacting people and what that will look like going forward if we don't make any changes. And also we have Tom DiLiberto. He's one of our newest members of Climate Central. He's our media director, and he recently was at NOAA for a long time, both as a climate scientist who is involved in the communication department. So we've got a wide range of people with us today to really get into the subject. First, we're going to set up the weather and the meteorological situation, and we're going to do that with Shel. So go ahead, Shel.
Yeah, thanks, Bernadette. Howdy, friends. Shel Winkley, been in Texas and forecasting here for almost 20 years now. And we've seen floods in the state of Texas, right? There's that old adage that Texas is the state that is perennial between drought and flood. But this is obviously one of the most impactful ones for the state. So we wanted to set this up because there is a very big weather part to this. So just to give you an understanding, right? So let's start with the weather maker itself. And it's interesting because a lot of folks that we've talked with have said, I didn't even realize that Barry was a tropical storm that existed in this hurricane season yet, right? It was just a very short-lived tropical storm, moved through the western side of the Gulf of Mexico, and then made landfall, the weekend before that this flooding occurred. But once that happened, the remnants of that system moved through northern Mexico into West Texas, and then essentially got stuck in the state, a roadblock in the atmosphere, if you will. So high pressure over the desert Southwest. There's an area of high pressure over portions of Arkansas, Tennessee, Kentucky. And then you had that big low pressure system that kind of was part of Tropical Storm Chantal over the Gulf of Mexico and then into the Atlantic. And then at the surface, we also had high pressure that was steering in some moisture that we'll talk about. But all that to be said, that's the reason why this weather system was just meandering and stuck over central Texas and the Texas Hill Country, and then was available to make the weather system that came together to produce this rainfall. When it comes to the moisture that's associated with what this was tapping into, and we'll talk about the climate change connection in a bit, the low level moisture of this was being funneled in from the Gulf of Mexico, which we know was above average for this time of the year. And again, we'll make that connection here in a few. But that excess moisture from the Gulf of Mexico in the low levels, and then the upper levels being pulled in from the Pacific. But another tropical tie here is that we had Flossie in the Pacific Basin that was winding down, but we were able to pluck some of that tropical moisture and bring it into the Lone Star State as well. So when you put those two together, that essentially put us in what's called precipitable water. So think about this as the water available to make rainfall, right? It was in the 99th percentile, meaning that it was in the top 1% of moisture content that's recorded for this time of the year. So all that to be said is that the atmosphere was just chock full of moisture for this weather system to tie into. Now, you've seen a lot in the news about Flash Flood Alley. This is an area of Texas that spans from about I-35 to the west, and particularly when you get into the hill country. So the thing that makes all of us Texans flock to the hill country is the same thing that creates such the dangerous conditions when you have weather events like this in this flash flood alley. So it's an area that's very hilly. The riverbeds go down deep. It's limestone. It's rocky landscape. And so what that means is a weather system that forms over the top of it, the winds that come up that topography can enhance these rainmakers. But at the same time, it's that topography, that heavy rain, especially to the excess that we saw in this rain event, can rush down and then flow into the creeks and the rivers. One more piece of this is that this part of Texas, at least in the Kerr County flood specifically, was in an extreme to exceptional drought. So that's the worst drought conditions that you can have. And we know that since May, temperatures have been above average, and there's a climate change connection there as well, which kind of bakes the ground, makes it harder. So any heavy rain like we saw is only going to have more of a tendency to rush and not be able to seep into the ground. Although with the rainfall rates that we saw, that would have been hard for them to do as well. Just to break down some of the stats that came from this, right? We know that there was anywhere from 10 to 15 inches of rain that fell over the Kerr County area. And then the following day, not to be neglected, is the heavy rain event that happened just to the northwest and north of the city of Austin as well. So two big rain localized spots that are, not unpredictable, but very hard to say exactly when and where these will fall. Between 4 a.m. and 7 a.m. on July 4th, the Guadalupe River rose from about a foot to over 37 feet. And for perspective, the areas that were impacted major flood stage is about 20 feet. So this was above major flood stage by over 17 feet. And again, this rain came and that wall of water came within minutes. So the National Weather Service did put out a couple of those particularly dangerous situation flood warnings as well. A lot of the flood gauges on the rivers between these two areas of flooding were damaged or destroyed because of the flooding and the debris that came with it. But what we know is that, again, 10 to 15 inches of rain fell in Kerr County. The Kerrville gauge, I was looking this morning, some of the great meteorologists across the state of Texas sharing information, the third highest on record as that water came through. And then in the Austin area, about 22 inches of rain fell, as being reported by KI, the CBS affiliate there in Austin, fell on the San Saba watershed, which sent the river to the second highest crest on record. 6 feet higher than the 2007 floods, if you're familiar, in the city of Georgetown. And also 10 to 20 inches of rain fell on the San Saba watershed. So for McCulloch County, that was the highest crest on record that they had seen because of the rainfall that happened over the weekend. So Kerr County, Texas, Travis County, Williamson County, Burnett counties are just some of the areas that were impacted by this weather event. And it's important to note that it's still here, right? We still have a lot of tropical moisture moving in. Some more rounds of heavy localized downpours are expected across central and southeast Texas today and tomorrow as well.
Thanks, Shell. And there's a lot of data in there. For those that may need some specific numbers or clarification on that, just follow up in the Q&A and we can make sure you get the links to this data and this information. So getting into the climate connection on this, and since attribution science, which again is that branch of climate science, which can really quantify the role of climate change within individual events, has advanced so rapidly and has come so far because of your great work, Fredi, people who are attuned to attribution science immediately are asking for, do we have an analysis? What would that look like? And I've been answering two different ways, but I'm curious to hear where you're going to go with this. One, there's a lot we can say on the connections between heavy rain and climate change, even without an attribution analysis. But then that's where we can get even more detail when we have the ability to do that. So I'm going to hand it over to you for you to answer that question.
Yeah, so the attribution question in this case is actually quite a difficult one compared to many of the other extreme rainfall events that we have seen in the past, because as Shell has just explained, what happened here is that, and what caused these massive impact is that a huge amount of rain fell in very few hours. And that is something that we see across the world, and it's also something that we expect to see in a warming world, that because we have a warmer atmosphere that can hold more water vapor, that in any given instance of such a weather situation as we have here, there is just more water that can come down. And we particularly see that in these very short, so on the time scale of hours, rainfall events. And that is something that where we have done, we as in the community, not necessarily our team personally, studies looking at the changes in hourly or a few hour of rainfall, and found that there we particularly see an increase because of human-induced climate change. But it is something that is really difficult to do in a rapid attribution study because almost all the climate models and almost all the publicly available climate data is only available on daily timescales. And while, of course, we see an event like this in the daily time series, that is not what really causes the impacts. And so it's not something where we can do an attribution study quickly with the tools that we have available. So that is something that will, in this case, unfortunately take a bit longer to look into how exactly climate change is playing out in this event. And there's an additional factor that that is in particular this region in the summer in Texas, but also the wider region in the sort of Midwest of the U.S. This is one of the few regions in the world where we actually see no change in the daily extreme rainfall at the moment. But I just looked again at the IPCC projections for even warmer climates. We see sort of emerging from a bit over 1.5 degrees, we see that actually then also there is a signal in the daily rainfall. So that probably means that if you would just look at the daily available time series for rainfall in the region, we might not see a climate change signal. But that doesn't mean it's not there, because it probably is there for sure in the shorter time series, which are harder to analyze. And also, as Shell said, data has been, reporting system have been destroyed, so it's really hard to find out exactly what happened, and we don't have the models. But if we continue to keep burning fossil fuels, and we will reach temperatures of above 1.5 degree of global warming, at the moment we are by about 1.3, then we will probably see also, even in the regions of the world where that at the moment are not quite as impacted as others, where the climate change signal and daily rainfall hasn't emerged yet, that will also happen. So it's really something we have to be prepared for, even when we can't show exactly at this point in time how climate change in a quantitative sense affected the region.
And what's interesting in that is that we have advanced science so far through data, instrumentation, scientists, and we're at a time when a lot of that's at risk and being pulled back. Whereas what I'm hearing from you, not to put words in your mouth, but is this is a time we need more data, science, and scientists so we can better understand how this changing planet is impacting our daily lives and what we can do about it.
Yes, yeah, very much so. Because while we have made huge progress, as you've also already said, on understanding how climate change affects weather, particularly for these local scales, for these small scales, and on the on the scales that are happening in a few hours, it's something where you need really high resolution climate models, which are they do exist, but they are very expensive to run, and therefore they are not run in. So we don't have many realizations of possible weather in this changed world we live in. We just have the observations we have and the few model runs that are out there, and that gives us an idea, but it is not enough to really understand how climate change is truly impacting these events. Again, which doesn't mean that it's not impacting them. It's just that this is one of the types of event where we really need more research to be better prepared.
Exactly. And again, to journalists out there, it doesn't mean there's no connection. It's that there isn't a specific attribution study yet on this event. But we do know a hallmark of climate change is that a warmer atmosphere can hold more water vapor, moisture. That is classic physics and physics equations. So now we're going to bring in Tom in this conversation, who, as I said, most recently was at NOAA. And this is really critical to this conversation because the other topic that's come up is with the cuts we've seen, in NOAA, in our National Weather Service offices, and across the board through our federal agencies with FEMA, USGS, which does a lot of stream gauges and river gauges, that how or if that's playing out in this way. So could you take us through, just to really ground this conversation, because not everybody lives in this space. So could you take us through when there's an event like this in a National Weather Service office, the lead up to it and during it, what happens, who's involved, how that plays out?
Yeah, absolutely. So, each office across the country kind of has different relationships with local county officials, emergency managers, but they have relationships with them and they're communicating with them on a relatively regular basis. Now, leading up to events where they expect to see extreme events occur, several days prior, they're probably starting to have those conversations. In this event, the forecast from the National Weather Service office in San Antonio and elsewhere in Texas were predicting there to be a good amount of rainfall, although they weren't predicting necessarily the 15 inches of rain that fell in certain places, which is much more difficult to predict well in advance. And specifically, also not only the amount, but the location of it. But they were warning of flood risks. And I believe the first flash flood warning came out at 1 a.m. on the 4th. And then there were updates to that warning with increasingly dire language until the flash flood emergency, which is a very rare thing to issue, was issued at 4 o'clock, roughly 4 a.m. in the morning. Throughout this entire time, the offices are generally communicating with emergency managers and local and state officials. The office in San Antonio is down people due to early retirements that happened earlier in the year. They're down a science operations officer, which is basically, think of that as like your head scientist for the office. And they're also down their warning coordination meteorologist. And that is the person whose job is to liaise with emergency managers and local and state officials. Now, that's not to say that didn't happen during this event. It certainly did. But what happens, and this is shared not only in Texas, but at weather forecast offices across the country, is that the people with the most experience dealing with these extreme events, but also communicating it, have left in a lot of places. So you can't necessarily replace that experience and you can't necessarily replace that relationship since the person left in April. The good news here is that the Weather Service was able to get the forecasts out. They had the people in the office to get the forecasts out, and the forecasts, the watches, and the warnings got out. But I think what this shows is that just because you get a watch or a warning out doesn't mean that the people that it's getting to understand the risk at hand. And it's a communications problem, and a communications problem, an outreach problem that relies on relationships, and it relies on a lot of work put in not during these sorts of flash flood seasons, but in the off seasons. And that is where my concern is when it comes to the impacts of short staffing in the Weather Service, is that when it is quieter, when you can start having these meetings with people, whether these offices have enough people to manage to get out of the office and have these conversations. Because while this is a tragedy in Texas, Flash Flood Alley, we know flash flooding happens in a lot of places. We've seen flash flood happen in a lot of places. We saw flash flooding in North Carolina this week. We've seen flash flooding up and down the East Coast, getting into the Central Plains, you name it, right? So these issues, while showing up clearly here in Texas, is something that's also a risk in a lot of other places across the country.
So this is a conversation just to bring everyone else who's on this webinar into the conversations we've been having internally. This is where Tom and I have gone a little bit deeper too, and just to expand upon a few of the things that he said. There's direct and indirect impacts from the cuts. And it's not just the National Weather Service. They're part of that full emergency management chain, which includes the local and the state officials, the first responders, the community leaders. And so we could have the best forecast in the world, but it needs to get to the right people at the right times in the right ways. And that is such a big part of how the National Weather Service has set up its office. It's why they have a warning coordination meteorologist to do that work. We understand that as a meteorological society. So I just want to add a couple of points to that the preparation is key here too. It's an ongoing relationship building where we strengthen and we practice and we prepare for the future. And especially at a time when we know these events are coming more rapidly and more intensely, it's even more important that we have those relationships. What I also heard from Tom is that expertise and experience really do matter. When you strengthen those relationships, you have that trust, that call at 2 a.m. when you see the waters rising to a camp. Could make a huge difference in this case too. And so that's where we have been spending a lot of our conversation time internally thinking about some of that. The other thing I want to highlight with this is that our forms of communication. So there's a few different pieces to this. One, with technology advancing and so many people having phones now, everybody having phones now, we have that opportunity to get warnings on our phones. Too many people are turning those warnings off. If you want to get the warnings in these life-threatening situations, you need the warnings on. The other thing is some of these areas have spotty cell service, and it doesn't mean everyone has a NOAA weather radio. I know a lot of us in our community do, but places where there are decisions being made or you're responsible for lives, NOAA weather radios work. They don't need electricity necessarily. You can plug it in, but there's batteries too, and they are loud and they will wake you up during an overnight. The other thing that's been a little bit of a discussion, and I'm going to ask you more on that, Shell, is about the flood warning system and what has or hasn't happened in some of these communities in Texas. And I also just want to stress too that we need to not only prepare for the climate that we have now, but for the climate that's coming. And we need to really take care of our youngest that don't always have the ability to make these decisions on their own. And that's where this one's hitting so deeply for so many people. So Shell, I do want to bring you in on the conversation a little bit on the warning service system. There's a lot of conversations around this, but I'm hearing more questions than answers right now. So could you update us from what you know on the flood warning system in Texas or this specific community or this specific area?
Yeah, so a lot of Texas, when you focus on particularly outdoor warning areas, most communities are thinking severe weather, specifically tornadoes. And a lot of that has to come from a couple different things. It has to come from either a county level, deciding that that's something very important. Where I live, it's not a warning system that they've done for severe weather, but they've really invested in a lightning warning system so that people will go inside and hear those sirens when there's lightning in the area. Specifically, some of the stories that have come out for the flood warning system along the river, that was brought up. And they brought that funding between county officials and the public itself. And, it was decided that it was too expensive or it wasn't worth the money to be spent. Similar thing in the community that I spent 15 years forecasting for. Every time that we had a tornado, either in or near the area, we'd always get the question about why are there not tornado sirens here in town to warn. And it goes back to the 90s when it was put up for a vote by citizens, and it was voted down because they didn't necessarily want to take that cost on and increase their taxes in order to put those systems in. So it's something that, outdoor warning systems are good for when you are outdoors, right? You have to have, we always talk about when there's a weather event coming to have multiple sources in order to receive those warnings. I know that when I go to bed, and I put my phone on the charger, it automatically goes into do not disturb mode. And one of the things that meteorologists across the state and I think across the country will always say is that on these big nights, when we can see severe weather, make sure that you leave your phone. I always said, leave your phone on, don't turn do not disturb on. And if you need to, put it right next to your head so that you can hear these warnings. So it really comes down to, even if we don't have these outdoor systems, which we can invest in and we can keep, not only invest in, but the maintenance that goes along with it. But also making sure that, like you mentioned, weather radios, your cell phone, if you have it and you're in a good cell service, those multiple ways to get these warnings is important. And I think that we especially learned that here. And even if that's an area that, as Tom was mentioning, the relationships between the National Weather Service and county officials or whoever, first responders, that last mile is extremely important so that we can get people to the places that need those warnings that may not be able to get there due to technology.
One other piece in the communication that I've had questions about is weather apps, right? So we know that's how a lot of people are getting their weather information right now. And there's a use to that and a utility to that. But it doesn't necessarily always give you the detail when you're in life-threatening situations or what could become a life-threatening situation. So one thing I'd advise people is if you follow your weather in your app, if it is not a normal situation or if all indications or if there are warnings popping up or even watches, and I should describe the difference because not everyone follows. A watch means the conditions are possible. A warning means the situation is happening. And so even if you're hearing it could be a high risk for some sort of type of weather, I encourage you to empower yourself to go a little bit deeper, to go to your National Weather Service office, to go to your local TV meteorologist, to get a little more information on what that means so that when you're in the potential risk situation, you have additional information of what community, what county, what road is at risk so you can help make decisions too for you, your community, your family to be safe. So weather apps are great for certain pieces, but when we need more, you likely need to go deeper and to have that ability to go deeper. That's another piece there. We're getting some questions now. So to get to some of these questions, one I saw is from Frederica Genovese saying that people are turning off weather alerts. Is there data on this? I'm not aware of any data. I just know from friends telling me this because I'm a meteorologist. So does anyone else have data on this or know where we could find it?
I don't have specific data, but I know just what anecdotally sitting in a restaurant in Austin one night as a tornado warning came through downtown Austin, I watched everyone's phones light up and I watched everybody look down and then swipe away and continue with dinner. So I think part of it's just we do have a lot of notifications coming at us, especially on our cell phones, and we tend to ignore a lot of them. So we've got to figure out a way to get that attention when it's needed.
So we had another question here from John Morales. This is for you, Fredi. And hi, John. Thanks for joining us. Dr. Otto says that no climate change signal may be detected in this event. Did I understand correctly that such a signal may only show in shorter timescales, but that data may not be available that way? If you could expand on that.
Basically, yes. So what the data we have globally available is of a resolution of daily data. So summed up the precipitation or rainfall that fell during 24 hours. And this event will show up in that data, but it will there will not be a really good way of characterizing what made this event special, because what really made this event so dangerous and had so strong impacts is that so much rain fell in very few hours, and that sort of these hourly rainfall that is in the weather observation stations that is available, and but often only within the last few years and not over a longer time series, which you would need to be able to really confidently detect the climate change signal. And so that's why if we look at sort of the data that we have available, and also daily data is only what we have available in climate models, because while climate models, of course, create data every 15 minutes, they don't do a very good job of getting the diurnal cycle right. That means that averaging over a day, most models are not bad. But when you look at these really dangerous short events, most models are really bad. And so we need what models that are called convection permitting. So models that are actually really simulating the rainfall processes on a very small scale. And that's just very expensive to run. And we don't have many of this, which means it would be something that would be hard to detect in the easy available data. But these kind of events are exactly what we expect from very basic physics to happen more of, because we know that a warmer atmosphere can hold more water vapor, and that means there is more moisture in the atmosphere, and that has to come out of the atmosphere. And therefore, when these atmospheric situations that lead to heavy rainfall are there is just more water to come down in a short time frame. And wherever we have data, we see an increase in this kind of events, but we don't always have the data to see that. And in particular, in rainfall on these short timescales that leads to flash floods is obviously what we're talking about here, and where we very consistently see a climate change signal across the world. But when you then have also situations like we do see in the Midwest, that on the longer term timescales we actually see it drying. So when you look at rainfall over several days or weeks and then the whole summer, that means that you have to look at the right data to really be able to disentangle these different systems and the different signals. And just because it's harder to do this doesn't mean they don't exist. And I mean, Shell was saying the drought was actually a problem because it made the soils even harder, and so the impacts of the flash floods even more severe. So I hope that sort of answered the question. It is unfortunately a bit messy.
I think there's a lot to get in there. So, but John, if you have a follow-up, do follow up. Larry Lenenschmidt asked this question, and several of you could answer. So jump in whoever wants. Some climate change deniers, is his wording, are pointing out there was a higher crest from another event. So climate change is not a factor. How would you respond?
I'll
Who wants to
sure. We all could talk about this, I'm sure. Right. It's similar to, let's say, a heat extreme day, right? There's been hotter days in the past. Does that mean that his temperature was not influenced by climate change? Right. And it's not necessarily, that's not the right framing of thinking about it, right? We're looking at the possibility and the changing of the percentages, the risk, so to speak. And then we're seeing an increased risk for seeing more of these events, for seeing more intense number of these events. So on an individual day, if you're comparing, and I always compare things to baseball, the worst team in baseball may win on a day where the best team in baseball loses. Does that mean that the best team in baseball is worse than that? No, right? These things have to be looked at on a whole and looked at in terms of increasing risk and increasing change. So while there may have been higher river levels in the past, we also don't know what that may have looked like in terms of river management in the past. Things get a little bit more difficult when you're thinking about just river controls as well. So it's not a direct comparison, and we have to take a look at it, as we've mentioned previously, the physics of this. Then a warmer atmosphere holds more moisture, you can have more rainfall falling at once, and we're seeing an increased risk and frequency and strength of these sorts of heavy extreme events. Anyone else would like to share their way of describing?
Yeah, I'll add just a little bit to that is that, one thing we haven't talked about yet is, Climate Central earlier this year put out analysis about just rainfall rates. Like, we know that in a warming climate with these warmer atmospheres and more moisture to tap into, our heaviest rainfall events are getting heavier. For Austin, those rainfall events over the last 55 years have increased by about 19% on the heaviest rainfall. And then for San Antonio, which is closer to Kerr County, that's about a 6% increase. So this is an area of Texas that is seeing both ends of the climate change spectrum, right? The droughts are becoming more intense again because that atmosphere is greedier and it can pull more moisture from the ground. So even with some timely rains, the drought's hard to get out of. But it's also seeing the impacts of this overabundance of moisture being tapped into. And when the rain does come, it is causing these heavier downpours and bigger, at least likelihood for flash flooding to occur. So it's a broader connection to climate change, but we know just through the data simply that there is a connection to climate change on top of what would have already been a heavy rain event for the states.
And sometimes that gets confused to people, this supercharging of the water cycle. And so just to break that down a little bit more, remember we are on a water planet, right? So when you heat up that atmosphere, it evaporates more moisture into the atmosphere. And that's where Shell means with the thirstier, the grittier atmosphere. It it is more thirsty, so it's pulling more of the moisture up. There's not always a trigger for that rain to come down, but when there is a trigger, whether it's a front, whether it's a dry line in certain parts of the country, whether it's a sea breeze front, whatever the trigger may be, there's more of that moisture to come down. And that's why we get more extremes on both sides. So just for a little bit of clarification there. Also, Jill, I have a question. It says higher crests. Have there been higher crests? Because from some of what I'm seeing, it was record, and a lot of these gauges may have even been knocked out. So I mean, maybe you can't confirm, but I don't know if there have been higher crests in some of those gauges.
Yeah, so pulling that was information that was released this morning.
Okay.
And yeah, part of that could have been because these gauges went offline, right? The ones near, especially in, closer to Austin as well. So that's something to be looked into, but at least with the data that we have, we know that these are some of, if not the highest crest, one of the highest crests of record. And I think it would be interesting to look, one thing that we don't usually report on is how fast those crests occurred. And I would be personally interested to know if there's that data to see if there was a faster flood event than what was experienced this past weekend.
Yeah, especially in the dark overnight during a holiday weekend. It's awful. So there's a question specifically for you, Tom, here about, can you comment on two ideas I've been seeing on social media? This is from Mary Lindsay. One, the degraded upper air network is having a real impact on short-term severe weather or extreme weather forecasting and impacting numerical model performance. That's one. And then two, the SSMIS microwave imager, and you may want to explain that to others, the sensor on that, on the Defense Meteorological Satellite Program, is being cut off from the National Hurricane Center. This data is vital to track many things, including rapid intensification of hurricanes as they approach land and sea. So could you comment?
Yeah, I'll take the first one, upper air network. Yeah, anytime that you're getting less data into models is not a good thing. So we have seen that weather forecast offices don't have the staff to do the weather balloon launches that they need to do. Whether we're seeing an impact in the numerical modeling and the performance, it's hard to say in the given season since we've just kind of seen this happen since, let's say, really February and March, or whether what we're seeing is just kind of the natural ebbs and flows of skill in weather models. And that is not only just American models, because these are this data goes into weather models that are run across the entire world. So just because we would necessarily see potentially a period where, let's say, the US model, the GFS is what they call it, the American model, is having a poor performance, it doesn't necessarily mean that it's just or it's due to the upper air network. It could just be the model itself. So I am sure there will be a lot of studies looking into the potential impacts of that. Whether that had an impact on this storm and this event, I would not think it probably had that much of an impact, looking at the broad amount of tools that the weather forecasters were able to use. Now, this
One extra on that, though, Tom, not just to sort of jump in on this conversation too, is one of the pieces of information that led into the forecast for a flood watch and flash flood warnings was an upper air analysis. And this is what Shell touched on in the beginning. It was at a pretty record high level for the amount of water all the way up through the column of air into the atmosphere. So that is one piece of data that led to a good forecast.
Right, but it certainly shows the value of that data. Mm-hmm. It's really hard to get observations through the column of air above us. And that's why weather balloons, even though I always say it's kind of silly, right? We're launching weather balloons in the year 2025, but they're incredibly important for those sorts of things that give the vital information. Now, for the second question on discussing the satellites. It's called a microwave imager. It comes from the Defense Department, and they allow that data to then be used by a variety of different organizations, including NOAA. And it's a way of basically looking at the atmosphere, piercing through the atmosphere, and looking at basically you can determine intensities of hurricanes. You can also look at it for sea ice, a variety of things. And the Department of Defense recently had told its users that it will be not providing the data anymore. So that is another tool that won't be available for forecasters as we get into hurricane season, as well as for all the other reasons that tool is used. I mentioned earlier, sea ice. So again, not an ideal situation. Whenever you have one less tool or a useful satellite being able to look at this sort of information, it's not something that is a useful thing. Now, I do believe that there's always a plan for something similar to come in the fall, or at least there's a kind of a gap in coverage. But again, for this event, not that much of an impact. For the hurricane season, obviously having one less tool is not something that you'd like to see, especially when it comes to rapidly intensifying hurricanes, which we know and we've seen in the years have happened very, very close to landfall, where we've seen storms jump from tropical storm strength to major hurricane strength in less than 24 hours. So not something great that we have to deal with going into this hurricane season.
Also, a plug for the fact that more data is needed at a time of a changing climate. So you answered some of this already, Fredi, but there's a couple of additional pieces if you want to expand upon it. This is from Lee Foy. Does the attribution science need access to more deeper databases to be able to do the analysis? And you've touched on that, but since the current administration is hostile to science and to climate science in particular, are there other players like the insurance agencies who would be willing to invest the money needed to advance more rapid attribution science analysis?
So I think the insurance industry is already investing in this, and I mean they have probably one of the best data sets for especially the what causes impact, that kind of data, and I'm not sure the insurance industry will now go and provide convection permitting models that scientists can use, because they are really expensive to run. And I think they are doing it more the other way around, that they are using the stuff that scientists put out and then do the extra step to look in how that links to the damages with their damage models. I mean, that's really where the insurance industry specifies in. I mean, the US is of course not the only part in the world where climate science is done, and there are other climate modeling centers, and also, I mean, also Europe has done quite a lot of convection permitting models, but they have been run over Europe. And because they are so expensive to run, you can't really run them for the whole world. So there is certainly there are some collaborations that can be done, but it is, if we want to understand better how climate change affects these kind of events, and it's not just to understand, to say, okay, climate change made this twice as likely. It's really to say, okay, this if this is what used to be maybe a 1 in 100-year event, and it's now a 1 in 50-year event. How does the 1 in 100-year event look like that now that we haven't experienced? But of course, a 1 in 100-year event has a 1% chance in any given year to occur. So it's something we want to be prepared for. So it's not just the retrospective analysis that these models are really important for, but also to be able to be prepared. And so it will really hurt people and lots of Americans if we don't have this data available. And it's not something, I mean, we already in a lot of the parts of the rest of the world, we already have a lot fewer data than in the US. And so the US has always been a place where we could study a lot and then learn from that also for the rest of the world. And if that is falling away, that will be that has a huge impact. And that's, I mean, it would be great if some industry would pick that up, but I think that's extremely unlikely, because it's not something you can make immediately money with. It's something you save lives with.
And you bring up a lot of good points there. And for those in the United States who aren't grounded in some of the global conversation, there is an initiative that's led by the World Meteorological Organization and supported more broadly as a key initiative for the UN as a whole. It's early warnings for all. We in the US are lucky to have a lot more data and information than a lot of the world. And those early warnings save lives. That's what we're seeing in this situation. And that's why it is so critical that we continue to reinforce them at a time when things are getting harder to predict and worse in our changing climate. So another question here, Shell, I'm going to give this to you since you're a Texas guy. And you've explained to me how this plays out in Texas more. And this happens in some of these ways around the country, but there are some specifics to Texas about, do elected officials, governors, mayors, representatives, et cetera, have access to and understand all of this data? So you're explaining the Texas emergency management system to me. Maybe you could help others understand that.
Yeah. So, you've got the National Weather Service, which we've talked about here. And I just want to reiterate, at least one of the Weather Service offices that I worked with as a broadcast meteorologist was the Austin, San Antonio area. And they are one of the most responsive offices in the state, right? I would say that they honestly over communicate even on the small events. So maybe that's a great thing that they have. So we have the National Weather Service, and we've heard a lot from elected officials about the forecast, how there was a flood watch out, but that nobody had predicted this much rainfall. It is important to note that Texas Department of Emergency Management, TDEM, also has their own meteorologists on staff. So not to say that they're at blame for not forecasting a 15-inch bullseye right over the Texas Hill Country that causes flooding. But it's the same as what we were talking about earlier with making sure that you have multiple ways of getting information and getting warnings. The state of Texas does have multiple ways of getting that information, right? And these are the best forecasts that were possible from some of the best forecasters in the Lone Star State. So to the short of that very long is yes, they have that information, or at least that it is available to them.
And so we've got two sort of comments here from two weather friends, long-term weather friends from our American Meteorological Society circles. Mike Mogul has been joining us, and he's been making some comments in there too about loving to get more data sources. So yes, another plea for that. And Joe Whitty also has been jumping in here too. And Joe always has something great to add for everyone to listen. But since you were recently a broadcaster and you spent a lot of your career broadcasting, Shell, recommendation to TV meteorologists and safety messages to viewers. We touched on this a little bit, but when you're in the backcountry or when you're traveling to a new place, how do you stay weather-wise? Is there anything else to add to that?
Yeah, that's tricky, because when you go on vacation, you're not necessarily turning on the TV to watch the local news channel, right? I do because I'm a weather nerd at heart and a local news junkie. But I think that really comes down to just having those reliable apps, the ones that will follow you. So your local news station likely has one of those weather apps. And as long as you have that location service on, it will follow you whether you're traveling in the state of Texas or across the country. And when those warnings are issued, you'll still get it from that trusted voice that you know. I don't know that anybody ever packs a weather radio with them as they travel. But maybe this is a good recommendation for the people in your communities that own either a Vrbo or an Airbnb, right? Like, this is something that could be provided as an extra amenity in these rental areas or even in hotel rooms, so that people can stay aware of the weather as they're traveling, especially in areas that they don't know the topography and they don't know the weather risks too. One more thing to add to Joe, because I've seen a couple of your comments on social media, is really talking about the topography. I'm really familiar more with the weather company's MAX system than I am Barron, but you can really zoom in close and ramp up that elevation to really show that. And maybe just going forward, if we know that a topography specific area is going to be a big part of the flooding story, that maybe we can show that on TV to really help people make that connection about what would happen if that much water, that lowest chance that Tom was talking about, comes together, like what that would turn into in terms of an actual weather event.
Thanks. You summarized this, Shell, earlier, but Maria Monica Monsalve jumped into. So if you could just do a quick explanation for her or anyone who joined a little bit later of, she said, so I understand a warm moisture wind was coming from the Gulf, met a cold front, and then there were remnants of Barry involved with this. So if you just do a quick weather setup for us once again.
Yeah, so the moisture supply, at least in the low levels of the atmosphere, came from the Gulf of Mexico, right? We know that they're running about 1 to 2 degrees Fahrenheit above average for this time of the year. And using the attribution science that Fredi has talked about so much is we know that those warmer, unusually temperatures are made at least 10 to 30 times more likely because of climate change. And we can share that link with you in the chat, but there's that another piece of that climate change connection. But what that moisture was feeding into, yes, the remnants of Barry, but what it essentially formed over central Texas is what's called an MCV, so a mesoscale convective vortex for the long scientific term of it. But essentially, it's a weather feature that can enhance rainfall, especially over this area. Again, Flash Flood Alley, one of the reasons that it is so prone to flooding is that topography allows the winds to rise up the topography into these weather systems, feeding them. So a weather system over this part of Texas might be able to produce more rainfall than it would have, say, over the Piney Woods or over West Texas. So it was that localized mesoscale system that was being fed by this very warm, moist air, more moisture than would typically be available in the month of July, that was able to come together and create this rainfall.
Great. We've got a couple of different questions here about, is it a 100-year storm, 500, 1,000-year event? And when you communicate in these terms, how is that affecting risk perception? Fredi, do you want to jump in on maybe the statistics around this?
Yeah. So whether you will find it to be a 100-year event or a 1 in 500-year event really depends on which aspects of this weather event you look at. And so it is not really the most useful information, I think, to give to people, because if you look at the daily time scale over a larger region, you will maybe find that this is, I don't know, a 1 in 50-year event or something that is extreme, but not something completely out of the ordinary. Whereas on a very specific location that has been hit, the amount of rainfall might be something that is much rarer. And so these 1 in 100-year event, 1 in a 500-year event, I think they are really helpful for sort of standardized ways of characterizing rainfall that we can compare across regions and that we can use to, say, build our infrastructure for, but to communicate how dangerous or how this is in it for people. I think if you say, oh, in your location it was a 1 in 1,000-year event, then people will think, okay, well, fine, that's over with. It will only happen in 1,000 years again, and that's of course not what it means. It means that even a 1 in 1,000-year event has a 0.1 chance of happening right again next year, but also it can be that a slightly lower amount of rainfall that would be still extremely dangerous is a much more frequent event. And of course, and then adding climate change onto that, what is a 1 in 100-year event will not be a 1 in 100-year event in 2 years' time if we keep on burning fossil fuels. And so I think to communicate, this is, I mean, it makes it sound dramatic and rare, but I think it's really difficult, even for people like me who deal with this all the time, to really imagine what that actually means. And so I think saying, okay, this is a very, very large amount of rainfall, something that we have never seen in the observed record, something yet you've never experienced in your lifetime, that's something I think that's more useful to say, to warn people. And then of course to plan how we need to adapt to this changing climate. We then also just need to calculate in different ways, sort of how vulnerable is this river basin to the rainfall here to rainfall in a different place, and the return time, so whether it's a 1 in 100 or a 1 in 200 year event, will be different, but that's not the most important information you can give out.
And then when we have infrastructure that's not even prepared for today's events, and they're changing and and that's also, even if you get a spot on forecast, what does that look like? I've never experienced it, and my infrastructure can't handle it. So there's a lot of questions, and we have 6 minutes left. I'm going to try and step through whatever I can in this moment. And if we could keep these a little bit tighter to get through as much as possible, I'm telling myself this. So David Yeomans, thanks for joining us, David. This is expanding upon some of the hourly data information you're putting out there, but he brings in a point with Harvey and the remnants of Harvey, and there was 10 to 20 inches in a day, and that was able to have an analysis. Could you just maybe explain the difference with this and with Harvey and approaching it? Fredi.
So with Harvey, what we had was actually a little bit the opposite situation, because in Harvey, that Harvey was so dangerous and so difficult was that the storm stalled. So it was lingering for a really long time over Houston, Texas, and so was dropping vast amounts of rainfall over if I can remember correctly, I think it was 3 days that it was really raining very heavily. And so that allowed us for Harvey to do an event attribution study very quickly, because everything that happens on timescales above a day is something where we have, especially in the US, really high quality data for, and so that is why we could do the attribution study for Harvey even at the time quite quickly. So it's really that the time scales of when the rainfall that caused the impacts was so different in these two events is what makes the attribution in this case much harder than in the case of Harvey. I mean, if I had to bet, I would probably say we would find a similar kind of climate change signal. So for Harvey, it was a bit above what we would expect just from the moisture holding capacity. So it was around 15% more rainfall. But for Harvey, because it was happening over these 3 days and also in a larger region, we had a lot of data to analyze that and to be able to really quantify the and in this case, because what really caused the impacts was on these hourly timescales of just a few hours in them, and of course also that it was night, but that it was in a few hours and in a much smaller region, that makes it more difficult to detect and really characterize the event in a way that we can analyze with the available data.
And that gets into, David, some of the difference. I mean, even the challenges we see in weather models, right? The smaller, the more finite, the shorter time frame, the harder it is to assess too. So Craig had this question. I'm directing it at you, Tom. Does anyone know how NOAA's Storm Ready program for communities has been or will be affected with the federal cuts and shifts in priorities? Also, there was a broader comment with a little bit of a question in it about maybe just making the point or taking us through briefly how all of these agencies interact in these ways, leading to such things as Storm Ready program, EPA, NOAA, NASA, DHS, OSHA, FEMA, USGS. All of them are at risk right now of cuts and lead to these safety and on the ground actions. So Tom, you.
Yeah, so I'm not sure about the Storm Ready program. I think usually that is pretty well funded and through the National Weather Service. The issue is that I feel folks don't oftentimes understand that when it comes to the research that goes into how the Weather Service words their warnings, words their watches, when it comes to some of the tools that help them improve the modeling for high impact rainfall events, when it comes to the people who are working on adaptation measures to minimize the risk from flash flooding, a lot of that work is not done in the National Weather Service. It can be brought over to the National Weather Service, but it's not done in the National Weather Service. It's done in the research wing of NOAA, the Office of Oceanic and Atmospheric Research, which, looking at that budget, is pretty much eviscerated in a lot of these ways. So a lot of programs that have worked on flood control mitigation measures, working with communities, that have worked on things like how do we better communicate that so it's not just turn around, don't drown. How do we communicate these flash flooding? Those sorts of impacts can also be cut. And then, as Bern mentioned, that these programs, they're not just happening in a vacuum. They're working closely together with NOAA. Works closely, very, very closely with FEMA, especially when we have these sorts of events. Sometimes there's literally a National Weather Service meteorologist stationed within FEMA for these things, so that they can make sure that the communication lines are open and clear. All of these cuts, whether it's NOAA or whether it's through FEMA, will eventually have impacts, especially as we get into summertime, where we're seeing more extremes happening across the country, where we might see the Weather Service and FEMA stretched to deal with multiple disasters occurring at the exact same time. The one thing I always say is that the folks within FEMA and within National Weather Service and all these other organizations will still be working their butts off to make sure that the best information is given to people. But we're asking a lot from less people, especially as we're seeing, again, certain extremes get worse and occur more frequently across the country.
There's so many more questions. I'm sorry we can't get to all of them. We are at time. I've been trying to step through all of it. I apologize to those we haven't gotten to. Thank you so much to everyone who's joined us today. You know how to get in touch with us at Climate Central. If there are some specific follow-ups you have, we are here to answer those questions. Also, just taking from this that we need to prepare. We need to protect our generations, our future, our current kids, let alone our future generations, knowing that this is only getting worse. So thank you all for your attention today and your caring about this, and stay safe out there.